Welcome to the AI Show by Brainwave Audio, Episode 7, where we bring you the latest in artificial intelligence and machine learning. I'm your host, Liam Foster, and with me, as always, is AI expert Ava Monroe.
Hello, everyone.
So, I think this is a deep dive you actually suggested.
I did.
About a paper called Diffusion-Reward Adversarial Imitation Learning, DRAIL for short. It's really about this cutting edge of AI, and how can we teach robots to basically learn by watching experts?
It's a clever approach
to
a key challenge in AI, getting machines to learn complex tasks without needing step-by-step instructions.
So we're not programming every single detail. We're kind of showing them examples and letting them figure out the rules from there.
Exactly. Think about teaching someone to play chess. Just letting them watch grandmasters play, observing moves and strategies, and start to develop their own understanding of the game.
That's a great analogy. So the paper is really focused on a specific method called DRAIL, and it kind of builds upon this existing technique called Generative Adversarial Imitation Learning, or GAIL. Could you give us like a quick rundown of how GAIL works and why DRAIL is such a significant improvement?
Sure. So GAIL uses two AI components, a generator that tries to mimic the expert's behavior, and then a discriminator that tries to tell the difference between the expert's actions and the actions of the generator. And they're constantly trying to outsmart each other. And in the process, the generator learns to become more and more like the expert.
It's like a game of cat and mouse, where the generator is trying to create these actions so convincing that the discriminator can't even tell them apart from the expert.
Precisely. GAIL has some limitations. The feedback from the discriminator can sometimes be very blunt. It's like just saying good or bad, without nuanced explanation. And that can make it hard for the generator to figure out what to improve.
So it's like a coach yelling wrong without giving the athlete any feedback. I can see how that would be tricky to train. And that's where DRAIL comes in, right?
Yes. DRAIL takes inspiration from a completely different area of AI. Diffusion models, you've probably heard of them. They're the technology behind those really amazing AI art generators that create like photorealistic images from text prompts.
Wait a minute. AI, art, and robots. They seem worlds apart. How did researchers connect those dots?
It's a brilliant insight. So diffusion models are really good at gradually transforming something chaotic, like random noise, into something really structured and meaningful, like an image. The researchers realized they could apply that same principle to make the rewards in imitation learning much smoother and more informative.
So instead of getting a harsh good or bad judgment, the AI agent receives more gradual feedback, and it guides it more toward the behavior.
Exactly. DRAIL introduces this thing called a diffusion discriminative classifier, and it assesses the generator's actions in a much more nuanced way. Imagine a coach who not only tells you if you're doing something right or wrong, but gives you specific guidance on how to improve your technique.
So it's less about passing judgment and more about providing helpful feedback that leads to like continuous improvement. What kind of results do they see?
The paper shows DRAIL consistently outperforms GAIL, or achieves comparable results, but with much faster learning times. They tested it on all sorts of tasks, from a robotic arm learning to manipulate objects, to a four-legged robot navigating to a location, and even really complex scenarios like a racing game using image-based state representation.
Image-based state representation. So the AI is learning directly from visual input like we do.
You got it. Instead of relying on predefined numerical data, the AI is processing visual information and learning from it, much like a human would observe the world.
That's incredible. So it's not just mimicking pre-programmed movements, it's actually understanding what it's seeing and learning how to react. And you said it outperformed GAIL in most of these tasks.
Yes, and remember how we talked about GAIL's instability? GAIL is much more robust, reliable, especially when the environment is complex or noisy. It's also incredibly data efficient, meaning it can learn effectively, even with limited expert demonstrations.
Okay, let's unpack that a bit, because I know collecting that expert data can be a huge bottleneck in AI development. How does DRAIL handle those situations where you just don't have a ton of examples to work with?
It's one of the most exciting aspects of the research. They found that even with significantly fewer examples, GRAIL could still learn effectively. This has huge implications for real-world applications, where expert data might be scarce or expensive to collect.
This is starting to sound pretty revolutionary. Faster learning, better generalization, more robustness, and data efficiency. DRAIL seems to check all the boxes. But I'm curious, how did they actually visualize and understand why DRAIL works so well compared to GAIL? Did they have any insights into what's happening under the hood?
They did. They visualized what's called the reward landscape for a simple task. Think of it like a map, where higher elevations represent greater rewards. GAIL's reward landscape was like a jagged mountain range, sharp peaks and valleys, making it hard for the AI agent to navigate.
So the agent was stumbling around in the dark trying to find its way to the top.
Exactly. But DRAIL's reward landscape was much smoother, like a gentle hill, making it much easier for the agent to learn and find the optimal solution. This visual representation really highlights why DRAIL leads to more stable and effective learning. Yeah, it's fascinating to see how a simple change in how the rewards are presented can lead to such dramatic improvements in learning. And that's what makes DRAIL so promising.
I mean, it really does feel like a game changer. And I'm already starting to think about all the potential applications. Beyond robotics, I know that's what this paper focuses on, but where else could this technology make a real-world impact?
The possibilities are vast. Think about healthcare. We could train AI systems to assist doctors in diagnosing diseases by observing patterns in medical images. Imagine an AI that learns to detect subtle signs of cancer that might be missed by the human eye, or to predict patient outcomes based on a combination of factors.
So we're talking AI that could potentially save lives by enhancing the accuracy and speed of diagnosis and treatment.
Exactly. And it's not just about reactive care. Imagine using DRAIL to develop personalized treatment plans. And AI could observe how different patients respond to various therapies and learn to predict which treatment would be most effective for a given individual based on their unique characteristics.
That would be a huge step towards personalized medicine, moving away from a one-size-fits-all approach to healthcare.
And don't forget about education. DRAIL could revolutionize the way we learn by creating AI tutors that adapt to each student's individual needs. Imagine a virtual tutor that observes how you learn best, identifies your strengths and weaknesses, and tailors its teaching style to maximize your understanding.
It's like having a personalized coach who knows how you learn best and guides you through the material in the best way possible.
Precisely. And think about how this could democratize access to quality education. Students in remote areas, or those who can't afford traditional tutoring, could benefit immensely from these AI-powered learning companions.
It's exciting to think about how AI could level the playing field, provide everyone with the opportunity to reach their full potential. But let's not get too carried away with the utopian visions. There are always potential downsides to consider with any new technology.
You're absolutely right. It's important to be aware of the potential challenges and to approach AI development with a sense of responsibility.
For example, we've talked about how DRAIL can learn from visual data. But what about the potential for bias in those data sets? If the AI is trained on images that reflect existing societal biases, could it end up perpetuating those biases in its own decision-making?
That's a crucial question, and one that researchers are actively working on. We need to develop techniques for identifying and mitigating bias in AI systems to ensure that they don't amplify existing inequalities.
And what about the impact on jobs? If AI can learn these complex tasks through observation, will it eventually replace human workers in various fields?
It's a valid concern, and it's important to have open discussions about the potential societal impact of AI. However, I believe that AI is more likely to augment human capabilities rather than replace us entirely.
So it's about finding ways for humans and AI to work together, leveraging each other's strengths to achieve better outcomes.
Exactly. We need to think about AI as a collaborative partner, not a competitor. This means focusing on developing AI systems that complement human skills and creativity, rather than simply automating away jobs.
That's a much more optimistic and I think realistic perspective. But even if we address those concerns, there's still the question of control. If AI is constantly observing, learning from us, could it start to influence our behaviors in subtle ways?
That's a thought-provoking question. It touches upon the broader issue of AI alignment. How do we ensure that AI systems act in accordance with human values and goals?
It seems like we're entering a new era where the relationship between humans and AI is becoming more complex and intertwined.
We are. And this deep dive into DRAIL has really highlighted the potential for both amazing progress and unforeseen challenges.
Absolutely. But before we wrap up this episode, I have one final, slightly out there thought. What if we take this concept of imitation learning a step further? What if instead of just observing experts, AI could learn by observing all of us?
You mean tapping into the massive amount of data that we generate every day through our online activities, social interactions, everyday behaviors?
Exactly. We're constantly generating data that reflects our values, beliefs, decision-making processes. Imagine if AI could learn from that collective intelligence.
It's a fascinating concept, but also a daunting one. We're talking about an unprecedented level of data collection and analysis, and the potential privacy implications are enormous.
You're right. We need robust safeguards to protect individual rights and prevent AI from being used for surveillance or manipulation. But imagine the potential benefits if we could get it right.
It would be revolutionary. AI could develop a much deeper understanding of human behavior, culture, societal dynamics. It could learn to predict trends, solve complex problems, and even create new forms of art and innovation that reflect the collective creativity of humanity.
It's a vision of AI that goes beyond simply mimicking human intelligence. It's about tapping into the collecting wisdom of our species and using it to create a better future. A truly mind-blowing concept. To think that AI could learn from the collective wisdom of humanity, it almost feels like something out of science fiction.
Yeah, it does, doesn't it? But the line between science fiction and reality is blurring more and more every day. And this idea of, AI learning from the masses raises some really interesting questions about, like, the nature of intelligence itself.
You mean, like, what does it even mean for AI to be intelligent if it's just reflecting the patterns and biases of its training data, even if that data comes from billions of people?
Exactly. It challenges us to think beyond traditional definitions of intelligence, which often focus on, like, individual capabilities, logical reasoning, or problem solving. What if collective intelligence, the emergent wisdom of a connected group, is just as important, or even more so in shaping the future?
That's a profound thought. We tend to think of intelligence as something that resides within individuals. But what if the most significant breakthroughs actually come from the interactions and collaborations between individuals and AI?
That's where things get really exciting. Imagine AI systems that can not only learn from our collective data, but also contribute to it, enriching our understanding of the world and ourselves in this, like, continuous feedback loop.
It's almost like AI becomes a mirror, reflecting back at us our collective strengths and weaknesses, our aspirations and our anxieties.
And in that reflection, we might discover new insights and possibilities that we never could have imagined on our own. It could lead to breakthroughs in science, medicine, art, and every other field you can think of.
But it also comes with a huge responsibility. If we're going to create AI that learns from all of us, we need to make sure that it's used for good, not for manipulation or control.
Absolutely. We need to be incredibly thoughtful about the ethical implications, ensuring that privacy, fairness, transparency are built into these systems from the ground up. It's not just a technological challenge, it's a societal one.
It seems like we're at a crossroads, where the decisions we make today about AI will have a profound impact on the future of humanity.
We are, and this deep dive into DRAIL has given us a glimpse into one possible path. A future where AI learns from us, collaborates with us, and ultimately helps us achieve things we never thought possible.
It's a future full of potential. And it's up to all of us to shape it responsibly, with a clear vision of the world we want to create.
Well said. As we conclude this deep dive, we encourage you to keep exploring these ideas. Think about the ways you're contributing to the data that AI is learning from. What kind of future are you helping to build?
That's a great question for all of us to ponder. Thanks for joining us on this episode of The AI Show, where we explore the latest advancements in AI and their impact on our world. We'll be back next week with another deep dive into the fascinating world of artificial intelligence.